Let us understand the concept of internal division of line segment. Now this is a very important topic for vectors, but we'll start with a very simple example and then extend it to vectors. So what I have here is a coordinate plane with a line segment PR. Now let's look into the question which is pertaining to this line segment. It says, find the coordinates of the point D that divides the given line segment PR internally in the ratio of 2:3. What does that mean? It means that we need to find a point D which is in between P and R so that it divides internally, means between them, in the ratio of 2:3. So somewhere in between we have to place a point D so that the line segment gets divided into two portions whose ratio is 2:3. So that is the question. Now how to do it? Now in this simple example, it's kind of simple. For example, this is line PR. It's going from 0 to 5. I can divide it into 5 equal parts, which is 2 plus 3 is 5, right? So those parts are 1, 2, 3, 4, 5. Now point D should be so that it divides PR in the ratio of 2:3, right? So obviously point D should be here, right? So that is our point D. So let me write down point D now here. And since we have a coordinate plane, we know D is 2, 1, correct? That is the coordinate for point D. Ratio 2:1, this P to D is 2 for us, and D to R is 3, 1, 2, 3. So D divides PR in the ratio of 2:3. Simple. So we get our point in this particular case. Now let's extend it to vectors and see how to find the coordinates of this point D given points P and R. So in this case, if you see, what are points P and R? Point P, the coordinates are 0 and 1, correct? And for R, the coordinates are 5 and 1, correct? We need to find coordinates of point D. So what we can do is we can treat external point O, which is the origin, and from here let's look into the position vectors OP, OD and OR. Now if I can relate OD with OP and OR, OP and OR are known to us, then I can find OD. Once I get the position vector OD, then I know the coordinates of D also, correct? So that is a strategy which we are going to use in vectors. Now let's work it out. How to find relation between OD, OP and OR. So that becomes our problem now. Let's start with saying what is relation of PD with PR. We can say, well, PD, vector PD now, is collinear with PR, it's a scalar multiple, right? So if I divide PR into 2 plus 3, 5 parts, then PD should be 2 parts, correct? So PD is 2 over 2 plus 3 of PR, right? So that is what PD is. I'm purposely not adding them for now. Okay. Now, so we get some relation between PD and PR. We need the relation between OD, OP and OR. So PD can be written as OD minus OP. So let's do that. So OD minus OP equals to 2 over, let me write 2 plus 3 still, PR will be OR minus OP. So OR minus OP. So from here we can isolate OD and get the value of OD. So we get OD equals to, let's take OP on this side. So we have 2 over 2 plus 3 OR. Let me write OP first, plus OP, and then minus 2 over 2 plus 3 OP. Now from here we know what OR, 2 over 2 plus 3 OR, that's the first term, and here we get 2 plus 3 is 5, so 5 OP minus 2 OP will give me 3 OP, right? So I'll get plus 3 over 2 plus 3 OP. So that is how I get the value of OD. So I know vector OD is 2/5 of OR plus 3/5 of OP, and this 2 plus 3 is the ratio 2:3, correct? So in general, if I would have had this question as in the ratio of, instead of 2 over 3, if I replace this with m is to n, in that case I can generalize my formula, right? I can get OD equals to, 2 is m for me, so it is m over m plus n OR plus 3 is n, so n over m plus n OP. Do you appreciate that? So basically, if the question would have been any ratio, we could have found a relation, right? Now since OD is our position vector, we know the coordinates of D. So coordinates of D will be, we can find from the given coordinates of P and R, correct? So that's how we can do it. Now let's solve for this particular question now. We know what is OP. OP is 0, 1 and OR is 5, 1. Right? So getting back to the question, that is to say that I gave you a general formula, but now let me get back from here, right? So we'll find OD, solve the question now. Okay. But I think you got the concept. It's not very difficult. We can always find D for any general line using this formula. That is kind of important, right? So we get 2 over 5. Let me now write down. Since we know it's 2:3 ratio, 2 over 5 of OR, so O to R is 5, 1, right? Plus N is 3 for me, so 3 over 5 of OP, which is 0, 1, right? So let's add these vectors. So 2 over 5 gives me just the number 2, and then this is 2 over 5 plus 0, 3 over 5, correct? Now, so let's combine them since I'm running out of space. So what I'll do now is switch over to this side, okay? So 2 plus 0 is 0. So let me write down here as OD equals to 2, and 2 over 5 plus 3 over 5 is 5 over 5, which is 1. So I get the coordinates of D, right, which is 2, 1. So D should be 2, 1. Let's check. So D is indeed 2, right, and then 1. Perfect. So we get our answer that D should be 2, 1, right? But I hope with this simple example you understand the concept, the big thing. So what we will do now onwards is that we'll kind of generalize and we'll not make this kind of a small sketch. So from now onwards we can actually use this formula OD equals to m over m plus n OR plus n over m plus n OP to find a point which internally divides the line in a ratio of m is to n. I hope you appreciate it. Thank you and all the best.